Hello, algebra students. Mr. Lawrence here, and this might be a review of something we talked about in class today. I'm not sure how far we were going to get before you watch this video. So this might be brand new, but then again, it might be an extension of what we were doing. It all depends on how you were doing with the previous lesson. So anyway, let's get down to it. I'll pretend like you don't know anything, but if you do know about it, then just pay attention for the review portion until I get to the new stuff. Then you can join right in. All right. Now, let's say I had to graph this equation y equals x. Now, I hope you guys know that it's in y equals mx plus b form or slope-intercept form. And we can identify the slope and the y-intercept and graph it really easily. That should be a simple thing to do. If you don't know how to do that, you really need to come in for some help and say, hey, I don't know how to graph in slope-intercept form. Anyway, I'm not going to do it that way though, because I'm going to use this basic idea to show me how to graph an absolute value function like this one down here in red. For right now, I'm ignoring the one in red, but I'm going to use a t-table here, and I'm going to plug these numbers, chosen very specifically, um, in for x, and I'll get my y's out. So when x is 2, well, it would be y equals 2, right? And when x is 1, y is 1. And when x is 0, y is 0. And so right now I have these 3 points. I have a point here. Let's see if I can just infinitely clone him. It'll make my life a little bit easier instead of trying to draw a whole bunch of points. I have a point at 1, 1, and I have a point at 2, 2. Now, in most cases, you'd say, hey, I've got 3 points. I can draw my line and I'm good to go. Well, just hold the bus for a second. While I do agree that part of your graph is going to look just like this, and tell you what, I'll change that color and thickness there. Okay, we'll make it this kind of a turquoise color. All right, watch what happens in my t-table when I plug in the negatives. Okay, well, I get a -1, right, and -2. So, oh, Mr. Lawrence, what's the big deal? It's doing exactly what you thought it would. Yeah, it's going to go on like this forever in both directions, and of course I need an arrowhead on the other end, right? Okay, but come down to this y equals the absolute value of x. And when I do this one, I plug 2 in. The absolute value of 2 is 2. Absolute value of 1 is 1. Absolute value of 0 is 0. So you might think, hey, I'm getting the same exact thing. Well, this is where it diverges. Because when I put a negative in here, absolute value of -1 is +1. So what ends up happening, absolute value of -2 is 2, right? Because distances are always positive. So what ends up happening here is I get the same graph like that, but it breaks and makes a V off like this. So you see it's actually a little bit different. It has a vertex. The vertex happens to be at the origin, and we're going to talk about how to get the vertex. It won't always be at the origin. Uh, it does have a similar slope. I mean, the right portion of it, the right side of the vertex, I go rise 1, run 1, rise 1, run 1. But when I do the left portion, I rise 1, go back 1, rise 1, go back 1. So it actually has two different slopes. This side has a slope of 1 over 1, and this side has a slope of uh, 1 over -1. That looks like a negative over negative. It's not. Okay, so the absolute value functions will all have a V shape. They won't all be a 90-degree angle. The ones we do today will, but the trick will be finding the vertex. So let's go on down here and let's see what happens to y equals the absolute value of x plus 4. Well, let me ask you, what would happen with the equation of y equals x plus 4? Wouldn't that have a y-intercept of 4 and then you use its slope? Yeah, well, y equals the absolute value of x is the graph we just showed you. I'll put it up here, right? goes like that. Okay. There we go. Hold on one second. Okay, so there's a graph of y equals the absolute value of x, right? But when I do a plus 4 on it, outside the absolute value, that's going to move all the values up 4. So in other words, this 2 would actually become a 6, right? Let's find that 2. So 2 is here, right? It's actually going to be a 2 way up here, right? The 1 is going to be 4 more, so it's going to be at 1, 5. The 0 is going to be at 4. The negative 1 is going to be at 5. And the negative 2 is going to be at 6. So what's going to happen is the whole graph is just going to shift up. It's going to go from here, and it's going to move right up there, just like that. It's pretty simple. So let me change the color of that so it looks a little bit different. There we go. So this one here, this turquoise colored one, this is the equation y equals the absolute value of x. But the orangish one is the equation y equals the absolute value of x plus 4. What do you suppose would happen if we had subtracted a value here instead of adding? Well, it would have just moved the v down, right? Yeah, sorry about that. Went down too low there. Okay, so when we add or subtract a number outside, like the y-intercept, it just moves the v vertically that distance. Okay, what do you suppose is going to happen when I have y equals the absolute value of x plus 4 on the inside? You know, like that, the plus 4 is inside the absolute value. Well, let's go to our t-table and plug some numbers in. And I chose these numbers on purpose. Okay, if I put negative 2 in here, negative 2 plus 4 is 2. Absolute value of 2 is 2. So I'm going to be at negative 2, positive 2. Well, that point was on the original graph. That's fine. Negative 3 plus 4 is 1. Absolute value of 1 is 1. Well, that's a little bit different. When I put negative 4 in, I get 0, don't I? Okay. And so it's at the point 0, negative 4. Okay, negative 5 plus 4 is going to be negative 1. Absolute value negative 1 is positive 1. Well, look at that. There's my v. Negative 6 plus 4 is negative 2. Absolute value negative 2 is positive 2. So having the 4 on the inside shifted the v horizontally. And let me change the color of him. I'll do him straight in red since I did the t-table in red. Okay. So when I had an absolute value, something added or subtracted the absolute value, it moved it vertically, the v. If I did it inside the absolute value, it changes it horizontally. You know what? Let's hold on a second and test this. I just made up a couple sample equations here really quick. I'm going to practice moving my v to the different places based on what's going to happen, the vertical movement or the horizontal movement. So you see right here I have the position for y equals the absolute value of x, okay? Now if I subtract 3 from the absolute value of x, that moves everything down 1, 2, 3 from the original, okay? So what I'm going to do is I'm going to clone it, move it down 1, 2, 3, and we'll make them red. So there's the red equation right there. Okay. Now, if I subtract 3 on the inside of the absolute value, that's actually going to move it in the opposite direction. I don't know if you noticed that on the previous one. When we added 4, the whole v shifted left. It was the opposite way. When we added 4 on the outside, the v shifted up. But when we add 4 on the inside absolute value, it actually shifts left, which is opposite of what you would normally think. Okay, so I'm going to take this, I'm going to change its color to green. It won't be easy being green. Anyway, and so I'm going to put it right there, but I know it's going to be the same exact shape, except it's going to move 3. Which way? It's going to move opposite because it's a horizontal movement. It's going to go 3 to the right. It's going to go 1, 2, 3. And there you go. Okay, because I just changed this original color to black. Sorry about that. Not a big deal. There we go. Okay, now, so that means this one here, x plus 1, is actually going to take this v. We're going to clone it. We're going to change its color to blue. And since he's a plus 1, it's going to move 1 to the left. And look at this. I'm graphing these equations in like no time at all because they all fit the same shape or pattern. Now, tomorrow we'll get to something a little more complex, but for right now, this will work really well. Okay, now, got to clone one more time. Got to change his color to this olive kind of thing. There we go. Okay, and we're going to look. 2 is added to the outside. That just shifts him up 1, 2, like that. And there you go. It might get confusing to look at all of them. If you want, you can take one away. Like if this one's bothering you, just move it out of, maybe move it out of the way. I'm trying. There we go. Move them out of the way. Okay. I think he was right there. Anyway, okay. So let's go ahead and see what happens when we do both things. Well, it's real simple. Let me see if I can just take one of these V's here. I'm going to steal him. Okay. And I'll make him red. I'm going to start off at the origin. Pretend the equation says absolute value of x. But since it doesn't say the absolute value of x, I'm going to shift it. I know that this plus 2 shifts the entire thing up 1, 2. I know that this minus 1 sends it to the right 1. Boom, I'm done. How hard is that? This is crazy. All right, let me clone him and get a green one going on here. All right. Put them at the origin, right? Okay. Now, this minus 5 moves them down 5. 1, 2, 3, 4, 5. And the plus 3 inside the absolute value sends it left. 3, 1, 2, 3. Yeah, the whole trick is I'm just finding the vertex. Do you notice the vertex of each one? The vertex of this one is at 1, 2. The vertex of this equation is at -3, -5. The y-coordinate matches what would be the y-intercept. It's technically not the y-intercept. Kind of looks like the y-intercept, but it's not. So what's the vertex of this one going to be? Well, the x-coordinate changes signs, and then the y-coordinate stays the same, so it should be at 2, -6. So in other words, if I clone him, I'll make him blue. I'm going to put that vertex at 1, 2, 1, then -6. 2, 3, 4, 5, 6, just like that. And you notice the slope is the same. Yeah, pretty easy. Now, if you look at the origin here, did I move down 6? 1, 2, 3, 4, 5, 6. I sure did. And the -2 sent me in the positive direction 2 spaces. There you go. All right, that's your lesson for today. I'm going to sign off. Mr. Lawrence says, have a good night, everybody.